Okay, in this presentation we are going to look at an introduction to probability worked example. Really, this is what is called a counting problem, permutations. So you might see them in courses, permutations and combinations. So this is a permutation, okay? So this is to do with passwords. You must create a password of length 5 using the following characters: A, B, C, D, 1, 2, 3, 4. So that's the set of possible characters that we are allowed to use. Okay, you may assume that characters can be used repeatedly unless directed otherwise. Okay, so essentially you can make a password that it uses A twice and 2 twice. For example, A22AD, something like that, or D1212, something like that. Okay. Now, so here are our exercises. How many possible passwords are there? What happens if you only use letters? What if the first character cannot be a number? How many passwords contain at least one number? And what if each character must be different? Okay, so that's our exercises. So essentially you have to count out all the possible passwords according to those 5 exercises. Okay, so how many possible passwords are there? So you have 8 characters to choose from: A, B, C, D, 1, 2, 3, 4, and you need a password of length 5. Okay, so each position in the password can be any one of those 8 characters. Okay, so there's no limitations. So the number of possible passwords is 8 to the power of 5, which is 32,768. Okay, so keep a mental note of that because we're going to use that later on. So exercise B. So what happens if you only use letters? Well, if you only use letters, you have 4 characters to choose from, A, B, C, D, for a password of length 5. So each position in the password can be any of the 4 letters. Okay, so you can actually use all 4 letters or one particular letter 5 times. For example, you can have CC, CC, C. That's an example of a valid password in this case. Or A, B, C, D, D. Okay? So each of the 4 assignments, each of the 5 assignments are independent of each other. So we don't have any restrictions based on what has been chosen before or what will come later. Okay? So essentially the number of possible passwords is 4 to the power of 5, and that is 1024 possible passwords. Okay, so there are 1024 possible passwords if you only use letters. Okay, straightforward enough so far, but we're going to get more interesting now, a bit more complicated. What if the first character cannot be a number? So if the first character cannot be a number, you have 4 options for the first position: A, B, C, and D. And then after that, you have no restrictions. Okay, so we're going to split this up into 2. So we're going to have the first character, which we have 4 choices for. Okay, and then the remaining 4 characters, which we have 8 choices for. So the number of possible passwords is 4, that's the first character, times 8 times 8 times 8 times 8, 8 to the power of 4, which is the second, third, and fourth character. That is 4 times 4 times 4096. That is 16,384. So there are 16,384 possible passwords if the first character cannot be a number. Okay. So moving on to exercise D. How many passwords contain at least one number? So this is where we use some previous results. Okay, so essentially the approach to take here is using the complement rule. Okay, so when we see at least one number, that's a little clue that we should actually look at the complement of that, which is no numbers. No numbers are used in the passwords. It's all characters, which is something we looked at previously. Okay, so to find the number of passwords containing at least one number, we use the complement rule. Find the number of passwords that contain only letters and then subtract this from the total number of possible passwords. And this is essentially exercise A and exercise B. The total number of passwords again is 32,768, whereas the passwords that only contain letters is 1024. So the passwords with at least one number is the difference between the two. That is 8 to the power of 5 minus 4 to the power of 5, 32,768 minus 31,024. That is 31,744. So there are 31,744 possible passwords that contain at least one number. Okay, so the complement rule is the trick there. Now this is the last one, and this is where we stop the assumption that we can use characters repeatedly. Okay, so this makes things a little bit more complex. So essentially what we have here is, if each character must be different, first off, what we must do is choose the 5 characters from the 8 available characters and then arrange those characters. Okay, so the arrangement of those characters, that's one matter, and then just actually choosing a 5 from 8. So here we need to use the binomial operator, the choose operator, the binomial coefficient. From 8, choose 5. Okay, which is 8, or it's 8 over 5 in those brackets. That a vertical alignment of 8 and 5 in brackets, that's the binomial coefficient, or the choose operator, whichever way you like to verbalize it. And that is 8 factorial divided by 5 factorial minus 8 minus 5 factorial. So that is 8 factorial divided by 5 factorial times 3 factorial. Now this is a little bit of calculator work, but essentially it works out to be 8 times 7 times 6 times 5 factorial divided by 5 factorial times 3 factorial. So the 5 factorials cancel out, so we're left with 8 times 7 times 6 divided by 3 factorial, 3 times 2 times 1, that cancels out with 6, so essentially we are left with 8 times 7. Okay, so 56. There are 56 ways we can choose 5 characters from 8. Okay, now what we have to do is arrange these characters. So we have a set of 5 characters, okay, but once we use one, it can't use it again. Okay, so in the first case, for the first character, we have, or for the first part of the password, we have 5 characters that we can choose from. Okay, but when we move on to the second, one is gone, we can't use it again, so we've only 4. Then 3 for the third one. 2 have been used already, there's 3 left, so we've got 3 options there. Then 2, okay, then 1. So 5 times 4 times 3 times 2 times 1, that gives us 120. So therefore, the total number of passwords is 56 times 120, which is 6,720. So there are 6,720 possible passwords where each character must be different. Okay. And, oops, yeah, don't worry about that little glitch. Okay, leave it there.